Okay, so I just wanted to do number 5 as well, just to kind of give you guys an idea of how to work through this if you're still struggling. Okay, so let's give it a look. So the graph they give us is f of x equals x squared plus x minus 12. So we got to graph this. When we're graphing a quadratic, first step, see if you can factor it. So we can factor this. Two numbers that multiply negative 12 and add to positive 1, positive 4, negative 3. That's a case 1 trinomial. And if you're struggling with that, just go back to the Unit 2 form. I actually posted a factoring review, lessons and homework and everything. Give it a look. Okay, so if you think about this, at this point here, that means that we have roots of negative 4 and 3. And our vertex has to fall directly in between those two roots. So to do our vertex here, to get our x value, we just average those out. Negative 4 plus 3 over 2 equals negative 1 over 2, which equals negative 0.5. To get our y value, we are just going to plug in negative 0.5 into the original equation here. So negative 0.5 comma 4, I'm actually not plugging it into the original equation, I'm plugging it into the factored one. Doesn't really make a difference. Minus 3, which gives us 3.5 times negative 3.5, which gives us, I'm going to have to pull up a calculator here. I just realized I don't have one on me. When I sat down to do these videos, just kind of did this question on a whim. 3.5 times 3.5 is 12.25, so negative 12.25. So therefore your vertex, you have 3 points to work with. Your vertex is negative 0.5, negative 12.25, and then you have negative 4 and 3. So if we graph all these on the same graph here, we have negative 4, we have positive 3, and then because our goal is to try to connect the reciprocals at y equals negative 1 and 1, so it's kind of good to try to get as many points down here as we can. Okay, so negative 0.5, negative 12.25, and then I guess we want to find the y-intercept too. Is not bad to have, which in this case here is going to be at negative 12. 0 squared plus 0 is 0, minus 12 is negative 12, so like that. So now you're ready to graph this quadratic. You're just going to plot the points like so. So now that we've graphed the original quadratic, we can do a sketch of the reciprocal. So that there's f of x. I'm just going to call it f of x. And then I'm going to do the reciprocal here. I'll do it in red. Remember, we have a vertical asymptote at the roots, and then a horizontal. Try not to get my marker covered in black. At y equals 0. So how does this work from here? So it's going to connect at the 1 values. So in y equals 1 and y equals negative 1, like so. It makes these little sort of, I don't know what you want to call those. It's like half a parabola on its side. It kind of looks like a parabola that's been rotated to that kind of weird angle. And then we connect asymptote to asymptote, connecting at negative 1 and negative 1. And then it should reach its highest point where the vertex happens. Okay, so, and that's generally the trend for doing all of these. Okay, so the hardest part about this question really is just being able to graph the original quadratic. Once you do that, just make sure that you put vertical asymptotes at the roots of the original quadratic, and make sure that you connect it at y equals 1 and y equals negative 1, and then it should look like 3 graphs. And then I should probably label the red one as 1 over f of x. Okay. So now that we've got that done, let's just answer this last part here. So we have, I'm going to try to write really small here and fit all this on. We have f of x, and then we have 1 over f of x. So the domain of every single parabola is XER. However, the domain of the reciprocal is x can be anything, but it can't be -4 or 3. Like so. The range. The original parabola, its range is that y can be anything as long as it's greater than -12.25. The reciprocal, however, its range is that y can be anything above 0. So we're going to actually set this up as two equations. Y can be anything above 0, or it has to be less than that top part. The highest part that this is going to reach is the reciprocal of the y value of the vertex, which is 1 over -12.25. So y is less than -1 over 12.25. So there's your range. Basically, it can be anything, but it has to be above 0, and it has to be below the reciprocal of the y value of the vertex. Okay, so lastly, we're going to do some positive intervals and some negative intervals. So I'm going to draw a circle around those. So the positive intervals for the original, it's positive from -0.5 to infinity. So from -0.5, no, that's not true. What am I talking about? It's positive from negative infinity to -4. And then it's positive again from 3 to infinity. It's negative from the two roots, -4 to 3. Right? The original function is below the x-axis from -4 to 3. The reciprocal, however, it has the exact same positive-negative intervals. It's positive from negative infinity to -4. And then it's positive again. The red one is positive from 3 to infinity. And it's negative from -4 to 3. We're using round brackets because it never touches those. They're asymptotes. Okay, lastly we've got to do the increasing intervals. And then we've got to do the decreasing intervals. Okay, so the original function is increasing on the right side of the vertex. It's going up. So again, it's always as we move rightwards, on the right side of the vertex we're going up, on the left side of the vertex, so in other words, as we move right, this is going down. So it's increasing from -0.5 to infinity, and it's decreasing, I just did that wrong, it's increasing from, no, I did that right actually, it's increasing from, -0.5 to infinity, and it's decreasing from -infinity to -1.5. The reciprocal, however, it's increasing on the opposite, so from -infinity to -1.5. But remember, it's not doing anything in -4 because there's an asymptote. So we write negative infinity to -4, and then -4 to -0.5. I wrote -1.5 over there. That should be -0.5. And then it's decreasing from -0.5 to 3. So we're looking at the red one now. It's decreasing, it's going down on the right side of the vertex. And then it's decreasing again from 3 to infinity. So again, that's as we move rightwards. I find students tend to struggle the most with this interval stuff. It's actually pretty simple. That's why I put that number 1 question down, just so you can really hammer through it. I made another video and I put it in the forum running through that. So if you're struggling with it, that's okay. I swear, if you practice this, you'll get the idea. The key thing to remember is it's always we're always setting these intervals up as we move rightwards along x. So from -infinity to infinity. Hopefully you're getting it. If not, let me know. I'll do what I can. Maybe I can post some more just basic graphs and just say, give me the positive intervals, give me the negative intervals, give me the intervals of increase, give me the intervals of decrease, and hopefully that starts to click. I'd say that the hardest part about this question is just graphing a quadratic, because you got to kind of pull back to grade 11, grade 10 math, and remember how to factor, how to find that vertex, and then just create a parabola. After that, I mean, like whenever you have a parabola, let's say I have a parabola that even look like this. Okay, that just means I'll use green for this one. I have a vertical asymptote there. I have a vertical asymptote there. If this is 1 and that's -1, I'm going to connect at 1. Let's move this over just a little. And I didn't draw a perfect function here. Let me redraw this. Unfortunately, I had my parabola. It started moving back in the wrong direction there. I need something that looks more like this. Okay, there we go. I can work with that. So we have those asymptotes there, and then it's always going to connect at -1 and 1. And then in the middle, it kind of connects there, and then the sides, it approaches the x-axis and the asymptotes, like so. So that's basically the idea. That's easy. Some pretty basic steps there. The hardest part is just being able to graph the quadratic. So hopefully you're kind of getting the idea. Again, I promise you it's not that bad. It just takes practice. All right. Thanks.